All right, here in the linked list class, let's start by declaring a new method, public integer get kth from the end. We give it this k parameter. Now we start off by declaring two variables, two pointers, first and second. However, we already have a field in this class called first, so we should either rename this field to head, and then we can call our pointers first and second, or we could simply call our pointers A and B. I don't want to worry about this too much. So let's declare A and set it to the first node. Similarly, we declare B and set it to the first node. Now we should move the B forward until it's at the right distance from the A. So it should be k minus 1 nodes apart. That is very easy. We use a for loop for integer I, we set it to 0. As long as I is less than k minus 1, we increment I. In each iteration, we simply set B to B dot next. So we're moving the second pointer forward. Now, after this step, these pointers are at the right positions. So we move both of them forward until the second pointer reaches the end of our list. That is super easy. So while B does not equal the last node, we're going to move both of them forward. So we set A to A dot next and B to B dot next. Once we're done with this step, B is referencing the last node. So we return the value of the A. So A dot value. Now let's test our algorithm. So back in the main class, here we have a linked list with these nodes 10 to 50. Let's do a print line and get the last node in this list. So we get 50. That is working properly. What if k equals 2? We should get 40. There you go. What if we pass 3 here? Our algorithm is working properly. Now, what if k is greater than the size of our linked list? So here we have 5 nodes, but what if we ask for the 6th node from the end? Let's see what's going to happen. We got a null pointer exception, and we have to fix this. So let's see where this is happening. This is happening where we're moving both of these pointers forward. So we can do a null check here, but a better place to do this is inside this for loop. Because if our linked list has only 5 nodes, and we're looking for the 6th node from the end, we shouldn't be able to position the B to be 6 nodes apart from the A, right? So let's add braces here. So in this particular case, as we move the B forward, at some point, it's going to hit the end of our linked list. Now, what is the next node after the last node? It's null. So if B becomes null at some point inside this for loop, that means k is greater than the size of our linked list. So here we should throw a new illegal argument exception because k is too large. Now we could also do this at the beginning of this method. For example, we could write, if k is greater than the size of this list, we could throw this exception. However, in interviews, sometimes they say, we don't know the size of our linked list. So if that's the case, this is where you can validate the k parameter, okay? Now, let's run our program one more time. We don't get a null pointer exception anymore. Instead, we get an illegal argument exception. That is better. Now, what if k equals 0? We get 50. Now, we could say that k is not a valid argument here, so we could throw an exception, but I think that's a little bit too much. That's too much defensive programming. In this case, our program is not crashing and we're not getting a ridiculously wrong value. We're simply getting the last node in this list. So I wouldn't worry about this. What if we pass a negative value here? So -1. We still get the last node. Again, it doesn't bother me personally, so I wouldn't worry about this. Now, what if our list is empty? And we ask for the first element from the end. Let's see what happens. We got a null pointer exception. Take a look. Because our list is empty, A is null here. So technically, the right place to check for this is at the beginning of this method. Because here we set both pointers to point to the first node, and then we move the second pointer forward. If our list is empty, none of this should happen. So here we can check to see if the list is empty. We throw a new illegal state exception. Let's run the program one more time. The problem is fixed. Beautiful. So this is how you can find the case node from the end of a linked list in one pass.